Okay, thank you. First of all, thank you big thank you to the organizers for the opportunity to speak about the Verpass API, which is indeed part of the OpenStreetMap community. And that is why I will start to talk a little bit about OpenStreetMap. The important thing is it's not just the map, but it's general purpose geodata. We are offering a big, huge data set of geodata and not a map, and not mainly a map. And of course, it's licensed library. There had been a lot of discussion which license to take, but now everything has settled down to the open database license. Okay, it covers the entire world. It covers each and every subject. And it is maintained by a marvelous community. You see these dots getting light in the background. This is a day of edits in Great Britain. And whenever there's something alight, then that's an hour of edits in Great Britain. So you see there's even during a day, there's a lot of activity in a country. So you have, after a day, you have a different map from a country like Great Britain than the day before. So it's actually, we have 2.5 billion nodes, which amount to in total 40 gigabyte of compressed gigazipped XML data. And there are coming updates in each minute. So although it's great to have such a huge data set, it's difficult to process it. If you really want to process this, you would have to run your own server with not so insignificant computing power. If you just want to process this full data dump, we are offering a full data dump, the Planet OSM, which is produced roughly once per week. And it's not unusual to have 24 hours time to get this into a relational database. So that's where where the Verpass API comes in. An overlay only needs some 100 points, like the thing you see here. I've just made a map of all the power distribution lines in the Netherlands, and you only need a few hundred nodes to produce a proper map, and you don't want to deal with all the 2.5 billion nodes in this case. So the Verpass API supplies you with such a language, such that you can query the entire database and just get on time the result, including the latest edits. For example, these 6 lines suffice to get all the power line network of the Netherlands. Who uses the Verpass API? For example, this is just a standard use case where you have a Slippy map with a POI overlay. So they have quite few things to do. You have just to host somewhere a static HTML page. You can use open layers as a framework to get the real interaction. And the data supply from the data itself comes from OpenStreetMap, and the Verpass API gives the data supply such that you can move around this map and get always a list of, in this case, hotels or whatever. Another more innovative use case is indoor navigation. This is always very few places in comparison to the entire world have really the necessity to have indoor navigation. You won't have it out in the deserts. You would only have it in big buildings in the city. So this is also a case where once you know which building to consider, you want quite a few distinctive data set. And that's also where the data comes from the Verpass API, and somebody could concentrate on making a cool framework to present this data and not needing to worry how to get this data from the backend. So just to give an overview, this is really these 2.5 billion nodes I've cited. This is the OpenStreetMap database, and to keep the database running, even with a very small budget, the entire OpenStreetMap is running on about 25,000 euro per year. We have this database server, which has an API on its own, but this is dedicated only to editing software, not for data consumers, because they really need to to get synchronization, because otherwise you would get conflicts when you try to write back data that updates that were based on outdated data. So only those editing software should connect directly to the OpenStreetMap database server, and everybody else should run or use a data mirror. And this is why there's this whole ecosystem of data mirror servers. They all take the updates that are coming in from the OpenStreetMap database once per minute and process them to keep an up-to-date copy of the OpenStreetMap database. For example, even I don't have a mouse. Even the rendering software that does the well-known map on FOSDEM.org that a lot of talks before this day have been used. This is produced on a mirror server that then does all the rendering. And this is also where Verpass API is placed. It really keeps an up-to-date copy. And now you can have innovative applications, Slippy maps, or whatever you want without a dedicated backend, just by fetching the data as you need it with these requests from the Verpass API. I'll just present some additional use cases. For example, map making. There's a software Maperative where you could just download a certain region of data and then produce a map from it. And that's also, they don't need to worry about the backend how to get the data, because that's brought by the Verpass API. And they could put all effort in making a good rendering. So you could really have a poster of a map quite easily with the software. You could pull data into QGIS. There's even nowadays a plugin called QuickOSM that will help you to pull data from OpenStreetMap into QGIS, and so on. And of course, one of the probably most important is, for me, is the Overpass Turbo, which has somebody else, Martin Reifer, has written, which is the front end to make all these, queries, or to give to these queries immediately a reply how this looks on a map. So it's quite convenient to develop queries if you just could push on run this query and get the results presented in a map. It's of course of most use for those who are involved in OpenStreetMaps themselves. But to get you more involved into OpenStreetMap, I will just conclude with explaining some query examples. For example, we wanted to get all the post boxes in and around Brussels. That's just a two-liner. Looks quite complicated, but I'll start to explain this. The first thing is the statement node. OpenStreetMap data consists of 3 different types of data types. It's not organized in layers. It's one big data set. And there are nodes, which are essentially coordinates. There are ways, which are lists of nodes, and which don't carry coordinates. It's something that's often vexing for people, but it's just the way it was decided nowadays about 10 years ago. And relations, which are essentially lists of anything, nodes, ways, or relations. And in this case, in the case of the post boxes, it's quite easy because they are really, they have no spatial extents. We can be sure that these are nodes. This can't be ways or relations. So we can choose, we only need to choose nodes. For the sake of simplicity, I've chosen to supply a bounding box. This is the bounding box between 50.8 degrees and, yes, you can read this. And every object in OSM can carry an arbitrary number of tags. This is essentially what gives or makes content into the database. when you really get annotate these coordinates with the property of being a postbox or being something else, being a bus stop or being whatever. And this is a free text feature. So the best thing is, so one of the, for common things like postboxes or bus stops or schools or whatever, there are accepted key value pairs. For example, for postboxes, it's amenity postbox, and you can just select this, and then this will result in all nodes that are within this bounding box and that carry a tag amenity postbox. And then you get all the result. Of course, it's quite arbitrary to take this bounding box, and we would prefer to take instead only the results of Brussels. This is what I've done on this next slide. Now we only get the post boxes in Brussels, which are surprisingly few, but I... Okay. Okay, so I've just called the city of Brussels instead of the region. Okay. Let's see why. I've decided to query for an area which has the name Brussels. I wasn't sure what ends up in the name tag. This is a long and complicated issue. People tend, in particular in multi-language countries, do surprising things in the name tag itself, because you have to choose: do you put Dutch first? Do you put Dutch second? And do you put both in, or if you was just one? So, in such a multi-language country, it's often best to choose one language and to rely on that that the names are maintained in multiple languages. In fact, they are quite well. The mappers of OpenStreetMap are really good in completing these kinds of data, so you can really rely on that in Belgium the name FR tags are maintained. Okay, so the area that has been found has only been the city of Brussels. We'll have to look afterwards what's the name, or what's the French name of the region of Brussels. And everything else looks quite similar as in the case before. But in fact, these are three statements. I've decided to design the query language as an imperative language. Sounds quite surprising if you are used to use SQL. You would expect rather a declarative language. But the advantage is it's easier to debug. You can really say something has gone wrong after line 1, or something has gone wrong after line 2. And the second more important advantage is when you do a really a resource-intensive query, it's likely that it's also a quite long query. And as people are lazy, they will try to find a shorter thing and tend to use less resource-intensive queries. That's in so far a problem, as we are not running on big hardware resources. All the users from the world are, in fact, querying mostly the one public available instance. And so, as we have to share hardware resources, it's important to design it in a way such that it's easy for people to be responsible with resources. Okay, so let's go through this request. I have again searching for nodes, which has an amenity postbox, and which come from the area I've just found before. And then we just return these nodes. Okay. To make it a little bit more complicated, we are now going to search for banks. The special thing about banks is they are often hosted in a building. And in this case, it might be that people have chosen that the building itself is a bank, but it might also be that people have chosen that the building is something else and there is a bank branch in the building. Both points of view have a certain, or are in a certain sense correct, because you may have cases where you have a bank and something else in a building. Then it's quite clear that not the entire building is a bank. You have cases where the entire building has even been in history as being closely attached to this bank. Then you would intuitively say the entire building should be the bank. So you really have to search for both. You have to search for the node when the bank is just has just been mapped as a single point of interest, but you also have to search for the way in case that it is mapped as a building. Oh, it's a subtlety I haven't written on the slides. Areas are in fact represented as either ways or relations that have multiple ways as members, which is also a thing with a 10-year backward perspective. One would say it wasn't the most wise decision, but on a hands-on project you have these things. And so a bank could be a node or a way. We have essentially the same query as before. We are having an amenity, or we are searching for amenity equals bank. This is the tagging for a bank. And we are searching for the area. There's just a subtle difference. I've stored the area in a dedicated variable, the result of the first line, to reuse it multiple times. This is one of the areas where you really see that it's an imperative language, that you have to store the things in variables and then we read it again. But on the other hand, the most use cases are that you are either using it from JavaScript or Python or something else, which is imperative, and so people are used to handle these kinds of things. You just have to tell them that it's important to think of this. Okay, then we want to collect both. So there's a statement around these two statements that makes it a compound statement. We just want to return. These are these parentheses. This indicates that we want as a result the result of this and the result of this. So it's really the onion of the two results. The nodes, these one for example, come from the first line. The ways, these one for example, come from the second line. And finally, this is again one thing where the query language cares for the specifics of the data model design. We want to draw the ways, so we want to have coordinates. So it's just we have to tell the thing that it should add coordinates to the ways, although by standards, ways won't have coordinates. It's just to make it easy to use. So we can proceed with the final example. Oh, there's even one more. Okay. That's a short one. The only thing that has changed is we have only a single coordinate here, a single point of interest. And this is because I've changed this from out geometry to out center, which would collapse each geometry down to a single point. It's no fancy algorithm. It's people often ask whether I should use the centroid. The problem is you get all kind of weird geometries that might be there. That might be there for a way. You might have open lines. You might have closed lines. You might have, if you are thinking of relations, you might have a disk with a hole inside, and it's not so clear what a centroid should be the right, or where the centroid should go in such cases. So I decided to instead return to put a bounding box around the feature and just return the center of the bounding box. It's not something with particular good properties, but it's easy to understand what's happening. Okay. So one more is we want to search for banks of a specific bank chain. The first thing I've found when I've clicked on the results was named ING. I don't know if it's a particular bank here in Belgium. And the thing is, people tend to, it's like with the buildings, with the building problem, whether banks are nodes or ways. People tend to, if there is a bank with a certain location in a suburb, some tend to name it ENG and then the name of the suburb. For example, this could have the name ENG Etterbeek, but could also be that the name of this bank is bank or branch Etterbeek and the operator is ING. And So we have to search for quite a lot of variants of how it could have been mapped. But it's really what the query language accounts for, that you could handle all these cases of different all these cases of different styles of mapping, which are you can of course ask whether we could force the mappers to map it in a certain way style, but we don't want this, because this would scare away people, which is a big issue. We want to keep a healthy community. And also, often reality doesn't fit into a certain data model, and so we get quite a good feedback how reality really looks like if we keep the data model open. Okay. As I've just told, we could have the ing shortcut either in the name or the operator. These are the common ways to map bank chains or supermarket chains or whatever. Okay, so I could proceed with the final example. That's the one that you have been already seen before. As you may have noticed, there are some more lines. And this is thanks to this tool of Verpass Turbo, which allows to give the results a style. It's a really nice feature in this case. It's called Map CSS. And it's also a language centered around the needs of OpenStreetMap, and which would allow you to give in such a Slippy map overlay to give the features a certain design. This language is also reused in one of the most important editors, Geospatial. So, but I don't know if there are any use cases outside of OpenStreetMap. Okay, and so in the end, when you have all these, when you have all, whoops, whatever is happening now. Okay, when you have all these, when you have all these maps, you can quite easily, with a few lines of code, you can get quite a nice looking map that would visualize whatever you wanted to present. In this case, the power distribution network of the Netherlands divided by the voltage of the individual lines, which suggests that there is a certain parting into a northern and the southern parts with different networks. Okay, so to give a conclusion, OpenStreetMap has often the geodata for your project. Whenever you need general purpose geodata, then it's very likely that you would get good enough geodata from OpenStreetMap. And the Overpass API makes this data really accessible to the level that you only need a single page or a single tool, and you don't need to worry about how to get updates and so on. You just fetch the data set you need. Okay, I thank you for your attention, and I'm ready for questions. Yes?
If you want to use such data, should you cache it to server database, or should you render it or query it every time you want to render it?
I think usually you can just query it every time you want to render it, because if you really want to render it, you have quite a few data, and so it doesn't make too much load to query it each time.
What's the result format? Do I get JSON or something?
There are currently 3 formats available. One is JSON. It's not GeoJSON, mainly for the reason that that it's not so clear what's an area and what's not. You have really a dedicated conversion step to get out of waste areas. You are getting in return XML. This is essentially the XML that we also use internally in OpenStreetMap for communication. And you also could get a tabular view, which is a tab-separated list of entries.
Can you also do a complex geometries for your queries?
You can ask for polygons as boundaries. There is, to return the question, in Overpass Turbo there could be a suggestion of properties. In fact, there is. It's called Wizard. It's, if I go back, it's a German edition. I'm sorry for this. But it's also in the English edition. It's also called Wizard. If you click here, you could enter a thing like, for example, post boxes in Brussels, and it will suggest the query. I'm not in particular sure what happens in Brussels because I'm not sure if it is designed for these multi-language cases. Yes?
Can I do a query like find me the nearest street or what like city I'm in? Like
You can.
a city or something.
You can get the city where you are in. This is, it's called is in this query. And you just, when you have either a coordinate, it would supply to the query, or when you have a result of a former query step, then you would get with this comment all the areas that this point is inside of. Yes, of course. Or to be precisely, there are two different use cases. If you really want to work with raw data and debug what's wrong with the data, it's probably better to get the raw results. If you really want to be something that's sane and sensitive and intelligent, then you would use Nominatim, because Nominatim is really good at understanding what's happening with the data and correcting errors. Whether Overpass API is faithful in the sense of that you always get the raw data on purpose to allow debugging data anomalies. Yes?
Could you shortly describe the capabilities of going backwards in time?
Yes, it's you supply a certain timestamp between 2012 and now. It's 2012 because we changed the license then. It would make legal issues to have older data also. And then if you supply a timestamp, you would get the results as if they were at the point of that time. So you could easily get the data as it were last week.
So it would be possible to like see what changed in this area in last week.
Yes, that's possible. It's still under development, to be precise. So it's quite humble at the moment, but it's possible. You could get the data from last week, get the data from this week, and do the comparison yourself. Or you could even employ a special comment that is called ADIF that will return you only what has changed since the last week. Okay? That's a difficult one. None that I'm immediately aware of. There are some applications, but I don't want to. I'm not knowing one particular at the moment. So.
I've seen some quite cool maps for users that use the overpass to get data. Does that count?
What's the use case?
Get the list of, let's say, post boxes in your area, just or any other specific information of the supermarket.
Okay.
If I can jump in again, there is a French piece of software called UMap. It makes a map for you and lets you take data from the Overpass API and show it like that.
Yes, but I think it's not what he meant.
Yeah.
He's searching for an Android application that would fetch a particular piece of data, and I'm not aware if there's such a general Android application. Okay, are there further questions, remarks? The UMap is really something I could suggest to use. It's really great, but I think it's a talk on its own. So maybe we should encourage the UMap people to give a talk next year here in this room. Okay, then thank you again.